particular video, let us concentrate on writing an assembly language program for a microcontroller. Let us assume a scenario where a user or a programmer is asked to write a program to store 10 consecutive numbers in memory. Now, whenever they say memory, we have a option of selecting either an internal memory or an external memory. Usual way of writing a program is assumptions. We assume whenever I select an internal memory, I will be using 8 bits of address. Example 20H or 45H, etc. And whenever I am assuming an external memory, I will basically take 16-bit address like 8000, 9035, etc. All these addresses are in hexa format. This is the easiest assumptions we will make to make things easier for writing a program. Now let us coming to the scenario, that is the question being asked. Write a C program to store 10 numbers in internal memory. I want to store 10 consecutive numbers in internal memory. Whenever I say I want to store 10 consecutive numbers, correct, I will be basically choosing an 8-bit of address. Say in 20H, I have a memory something like a stack. In 20H, first number, so the next consecutive location will be 21H, 22H, so on till the last location 29H. Correct? If we count also, we will be having 10 locations. Here I am supposed to store 10 consecutive numbers. Now whenever I say 10 consecutive numbers, let us say I am storing the first number to be 00. 8-bit, so I am taking it as 00H. So in 20H I am storing the data 00. So what will be the second consecutive number then? So second consecutive number will be 1. The next number will be 2. So on till 09. This is what I will basically store. Good enough? Now let us derive the relationship between the addresses and the data. Now looking at the first two addresses, we can see from first location to second location the difference is 1. Similarly, whenever I see the data difference between two numbers is 1. Here also the difference is 1. Similarly, it continues. The relationship between first to second number is +1. So this is the logic for writing a program. Correct? Now for writing a program, let us write the logic first or an algorithm first. So I am just writing a logic here. Algorithm can also be written, that is putting everything in form of words. General English definition of steps is nothing but an algorithm. We can also develop a flowchart if needed. Here I am just concentrating on the programming part. So I am concentrating on writing a logic in the simplest possible way. What will I do? First I will select the location. Here I am selecting the location as 20H, first location. How many datas he asked you to store? He asked you to store 10 datas. So I want to count how many datas. So I am using a counter to keep a track of storing this number. So track of these data is 0AH or 10 in decimal. You can store any. Basically, I prefer you write all the data in hexadecimal number system because that is what my microcontroller is working on. Next, the relationship between first data to second data is basically +1. So if we have known this, then writing a program is very, very easy. So let's start writing a program. First of all, we require a preprocessor directive. So it is always a good practice that we start storing the program or data from the very first available location. That's a good practice, correct? So we don't want to store it somewhere abruptly. So from the very first available location, start saving the data, correct? So having to be done that, we have to do that. So what we'll do is, we will start the program from 00H, ORG 00H. ORG is a preprocessor directive which tells the PC or say execution control that the program is starting at the location 00H. But from 00 to 2AH we have pre-written codes. This is not to be disturbed. So what am I doing? I am avoiding that locations. So I am directly jumping to 30H. Okay, the pre-written codes, pre-written library files, I can say it in general, has to be avoided. All routines for microcontroller working is written here. So I am just avoiding that particular location. So from where will I originate the code? I will originate the code from 30H. That means my logic starts from 30H. This three preprocessor directives becomes important, correct? We cannot avoid these preprocessor directives. Having written these preprocessor directives, now let us write the program. Now we had assumed the first location to be 20H. I am initializing that particular location. Move R0, hash 20H. R0 I will be using as pointer later. Later R0 will be used as a pointer. Next, we just now wrote we wanted this I have initialized. Just now we also wrote that we wanted a counter of 0AH. So let's write that also. Move, I'll use the next R1 hash 0AH. Okay, here R1 is counter. Good enough, correct? Having done this, now I want to move 00 to the location, first location, that is 20H, pointed by R0. So I'll store that somewhere. Move A, hash 00H. If you want, you can start from 1. Okay, my assumption is I am starting from 0. This is my first data. Clear? Now these steps are called as initialization steps. I am initializing some values to the registers and accumulator. Having done that, let's continue. First 00H should go and sit in 20H. Let's see the table there. Correct? So we have to store 00 in 20H. So move at R0, A. Correct? A was having what? 0. What is R0? 20. At 20, I am storing 0 from accumulator. Correct? So first data is stored already. Next, what should I do? I should increment the value of A. So the next consecutive value will be 1. I have to go to the next location. So increment R0 also. So I am going to the second address and also incrementing the value. So the consecutive number after 0, the consecutive number is 1. Correct? After being done with this, what will I do? 1 should go to 21H location. I have moved one data. I should keep a track of how many datas are moved already. Correct? So to keep a track of it, what am I doing? Decrement. Jump on. No 0. What is the value I should decrement? The counter value. R1 is a count. After count is not, till counter is not equal to 0, I should loop back to loop name called as L1. What should I do next? Again copy 1 to 21H. Where am I copying that? I am copying it here. So you can see 1 is copied to 21. Again A is incremented. So A value becomes 2. R0 is incremented. R0 value becomes 22. 2 should be stored in 22. So I am populating the memory this way. 20H, 00 was stored. 21H, 01 was stored. 22H, 02 was stored. So on till the last location 29H, where I'll store 09. So this count till when I have to keep on doing it, it is counted by R1. Once R1 becomes 0, that means I have done all consecutive numbers being saved in the memory. So we have completed the work. I will end the program using a preprocessor directive called as end. So this is a program for transferring or saving consecutive number, 10 consecutive numbers in the memory. Here we have done using internal memory. If we want, we can do it using an external memory also. Hope this particular program or small explanation has helped you to understand on the importance of deriving a logic, then converting this logic into a program. All this is easy, looking easy only because we have already understood a instruction set. Please be aware of the instruction set before we starting any program. Thank you.